Oh, good afternoon, everybody. People are starting to trickle in here. We got quite a few signed up, and we got about a quarter of them logged on. I'm going to unmute Andrea here so she can say hello to everybody, and we'll get started in a few minutes. Good afternoon, Andrea.
Hey, Ryan. How are you today?
Not too bad. You?
Good, thanks. Yeah, we'll give people a few more minutes, like you said.
Yeah. We've got about 47 people signed up total.
That's good. Nice to hear.
Yeah, we got about a third of the group here now, Andrea. They're rolling
Okay.
in now.
All right. You want to get started then, Ryan?
There's no hurry on my part if you want to
You,
give it a couple more
okay.
minutes.
Yeah.
What I can do
Certainly.
is,
That's
while
fine.
we're waiting, I can jabber on about my MidNite, which is now out in its beta form. For anybody out there that happens to have a Classic, the Classic is internet capable, plugs into the router at your house, and you just simply go to my MidNite, create your account. And what we're looking at here is a plot of a week. This is a new Classic install that I just installed. This is only 4 or 5 days here, but you can see the distinct days, and you can see the different data. And you'll notice over on the left, the data is changing there. And if I go off screen, what you see on the left-hand side is the last call-in to the server. All the data about that call-in. But if I hover over the data points, you'll notice the time and the date, and everything changes. We can pick a whole bunch of different data that we can look at, change the graphs, and we can change the size of the graphs if you want to look at it more than one day. So my MidNite is starting to shape up really well. My MidNite's also going to give us things like email notifications, monthly reports on the system, and be able to set it up to email you the raw data for the month if you want, or whatever is needed. Just kind of a neat feature because it's very simple to use. There's no software. There's no port forwarding. You literally just plug the Classic into the router on site and create your username and password here at mymidnite.com. I won't talk a whole lot more about it. Like I say, I encourage everybody to jump on our forum. We've got a section on there called My MidNite Online Monitoring, alpha/beta testing. And we can, you go on there. I encourage you to participate. We're in stages now where we're actually molding a lot of the cool features in, so we're looking for a lot of feedback from people, what they'd like to see. Other than that, I think I'll turn it over to you, Andrea, and we might as well get rolling. We've got a pretty good group in here now, and we'll go from there.
Okay, that's interesting stuff, Ryan. Thank you. We just wanted to thank everybody for joining in on the webinar this afternoon. MidNite Solar has been a terrific partner of Alt-E, and we're looking forward to this presentation as well as more throughout the year. And for our full list of webinars, you can just go to our website, www.altedirect.com, and the banner is right there for the schedule listing, and that'll be listed at the end of the presentation as well. So I just wanted to say thanks again, and Ryan, I'll put it back over to you.
Okay, sounds good. I'm going to unmute Kim as well so she can jump in and interrupt me at any time, and we will get going here. Let me... And if the audio gets funny or anything, I've been having a little trouble with GoToMeeting, so if the audio gets funny, somebody raise their hand to holler at me, and I'll call in on my phone if I have to. But with no further ado, we're going to talk about MidNite Solar's pre-wired solutions for off-grid, battery-based grid tie, and AC coupled, and we're going to lightly touch on the classic charge controller too. I put the classic at the end, so depending on how we do for time, we can talk about it some more if I haven't put everybody to sleep by then. For those of you who don't know me, I am Ryan, Technical Support Manager here at MidNite Solar. There's my email address and my phone number. Feel free to call me anytime, email me anytime, help you out, answer your questions. I work in Maine, so I'm on the same time zone schedule as Alt E is, so feel free to rattle me first thing in the morning, no problem. So first questions would be, why pre-wired? And I love these pictures. I keep these pictures and use them. This is a homeowner installed system. Hold on a minute. I'm going to mute that. There we go. Sorry about that noise. This is a homeowner installed system. As you can see, they did use an E-panel, but they didn't route the wires through anything. So this is just, you know, how it's done. This is a pre-wired system. Shows you nice and clean, you know, simple to install. Basically, when you get it, it comes on a crate. It's all pre-wired and tested. Literally, all you have to do is bring your battery cables to it, your AC in, your AC out, then your PV in, and you're good to go. If it's an off-grid or grid tie system, if it's AC coupled, it's pretty much the same scenarios, and we'll talk a little bit more about that later. Just another example of stuff installed, and you know why pre-wired makes it nice. Again, this is a pre-wired system, nice and clean. Another pre-wired system, just showing, you know, the simplicity of it. So this is our E-panel, and this is what it would look like when you get it, except for the wires coiled up over here by the charge controller. Would actually be hooked up to an inverter on the door, and of course the cables will be hooked up. But what I wanted to show here is just how simple it was to install out in the field. You'll notice there's literally set screws. So you strip the wire, put it on the screw, tighten it down. Battery cables bolt onto the big lugs. Charge controllers all pre-wired in off the breakers. Just makes a really nice, clean, easy to install scenario. And like I say, I'll talk a lot about specifics on inverters and different situations here in a little bit. Again, like I was pointing out, this one shows the layout. PV positive bus bar. So you'd come in from your solar panels, go to this bus bar with your positive. You go down to this bus bar with your negative, and then of course your AC out would go here and here, AC neutrals in the middle, AC in from the generator or the utility grid here, and earth ground. You know, and each one of the E-panels is pretty much the same. The orientation of some of the bus bars might be in a little bit different location, but for the most part they're all going to be well labeled and pretty easy to follow. Picture of a dual Magnum AC coupled. You'll notice it's a little bit different, a little more unique. The right-hand E-panel has this big solid-state relay in it and a heat sink, and the reason for that is an AC coupled. We need to disconnect the grid tie inverter when the batteries get full, you know, if the grid is down. Otherwise, most of the inverters will keep on charging. Again, I'll talk a little bit about that in a minute here when we get more specifically in the AC coupled. And our new SMA E-panel, for those of you that use the Sunny Islands. We have a full line of E-panels now for the Sunny Islands. And we have the relay board in them too for the AC coupled situations when we do a single SMA Sunny Island in a grid tie application, which we'll talk quite a bit about in a little bit. Just another example of an AC coupled pre-wired. This is actually in an outdoor rated box, so if you don't have place for this inside, this whole system comes in a box. The batteries go on the bottom shelf. This is on the top shelf, and I just like this picture because, again, it shows how easy it is to hook up the stuff to it. A regular screwdriver, pair of wire strippers, and you know you're ready to go. So basically, what type of system do I need? You're looking at a pre-wired system, or you're looking at renewable energy in general. You have to figure out what you want to do. Okay, do I have the utility grid already there? And if so, do I want to be grid tied? And if so, do I want backup? So if you're starting from scratch, you don't have any renewable energy, and the utility grid is already there, and you want to do grid tie, then you have two choices. You want to do battery backed up grid tie, or do you want to be pure grid tie with no batteries? And we won't even go into purely grid tie here, just because you don't need a pre-wired system for that. But with pure grid tie, when the grid goes down, you do lose your power. There will be no power in the house because there are no batteries. So in order to have backup power when the grid is down, you have to have the batteries in the system, which now puts you into a battery-based grid tie system. The other two common types of systems that you'll hear referred to are off-grid, so there's no utility grid there at all. You want to be your own utility grid, you'll do an off-grid system, and with that you'll probably have a generator input to it for backup if the sun doesn't shine, for instance. And the third one would be AC coupled. And what AC coupled is, it's a retrofit, basically. It can be done for new installations too, but it's best suited for retrofitting a purely grid tie system with batteries for that customer that bought the purely grid tie system and then the power went out and decided, hey, I want power when the power goes out. So that's what AC coupled is. And we'll talk briefly about all three, off-grid and battery-based grid tie. A lot of the inverters do both, and we'll talk about that as we talk about the specific inverter as we get down through this. Something I do want to point out is all of our pre-wired systems are fully customized. They can be built per your spec. Each one is built with a custom drawing and shipped from our location. So if there's something unique you need, get a hold of Alt-E and we will be more than happy to do that for you. Like I say, there'll be a custom wiring diagram done. It will be built to that wiring diagram, and that diagram will ship with the product. So off-grid, basically, like I said, what off-grid is, it's a standalone system. It cannot sell back to the utility. Now, it can be utility interactive, so those can be a little confusing. Say you have the utility there, but you don't really want to use it, and you want to put a battery-based system in and be off-grid. Then you could do an off-grid system, and it will use the grid to charge batteries if need to, but what we call an off-grid inverter will not physically sell backwards to the grid or spin the meter backwards. Like I say, there are some inverters that do both, but as an off-grid inverter, it'll be a standalone system, will not sell back to the utility. Various inverters to do this with. There's Magnum, Xantrex, SMA, Outback. All the major players do off-grid and do it very well. The determining factor in determining which inverter you want, basically what you need to start out with is, do I need 120 or do I need 120-240? How big of an inverter do I need? And in the off-grid world, that's solely based on the biggest load you plan on running, or actually the opposite can be true sometimes. It can also be based on how big of a battery charger do you need. Some off-grid systems get pretty big battery banks, and when they do, you need a big enough battery charger to actually fill them. So sometimes I've actually seen extra inverters put in more for the battery charger than to carry the load. But for the most part, to size an off-grid system, the first thing you need to know is what's the biggest instantaneous load I want to run. That will give you the wattage of the inverter. And then you need to know, what is my consumption over a 24-hour period. And with that information, you can calculate out how many solar panels you need, how many batteries you need, how many charge controllers you need, what inverter you need. And Alt-E and us here at MidNite as well will help you with that, designing that system and picking the right components for that system, or even the right inverter, because quite frankly there's a lot of choices and they're all good inverters, so sometimes it can be a little intimidating. But again, basically to recap, off-grid standalone systems will not sell back to the utility. That's the big one to remember, is will not sell back to the utility. You'll also hear grid interactive mentioned at times, and that can be confusing. I've talked to a few people that have bought this particular model right here, this Magna sign as you see it, because it said grid interactive, and they assumed that meant it could sell to the grid, which does not. Grid interactive solely means it can use the grid to charge the batteries. It will actually say grid tie if it can grid tie. So here's a picture of a grid tie with battery backup. So again, to recap on that type of system, This system would be, you've got the utility grid already there, you want to do renewable energy, but you know you want backup power too. You're worried about the ice storm, or you're worried about the stability of the utility grid, or just power is a little flaky in your area and you want your own dependent power system, if you will. So what happens here is these inverters get placed in between the utility grid main panel and what we call a critical loads panel. And what happens is the inverters have their own automated relays inside, and anytime the grid is there, the two are connected together, and the renewable energy physically gets sold to the grid and powers the loads. But as soon as the grid goes away, they drop their relays, and they immediately start becoming off-grid inverters and powering the critical loads panel. So this type of system will do both. It will sell to the utility grid during the good conditions, and it will give you backup power when the grid is gone. So that's the beauty of a grid tie of battery backup. If you do have utility grid there, this is probably the way to go, pending, you know, utility permissions and stuff. You will need the utility's permission to do grid tie. Most states have something called net metering. Most utilities honor that. Some utilities have a lot better programs than others. You'll have to check with you know, Alt-E or your local utility to find out the answer to that question. Again, sells to the grid. It will run critical loads during a grid failure, whereas a pure grid tie system will not. A couple questions again that you need to know is, do you need 120 or do you need 120/240? And some models of grid tie inverters support generator input as well as utility input. And I'll touch on it a little bit more now, and I'll touch on it a little bit later. The particular inverter you see pictured there does not support generator input very well at all. If it's a grid tie inverter, it's the generator is usually not stable enough for these inverters to connect to. So if the customer wants grid tie with battery backup and they want to be able to bring in a generator under those extreme conditions, then you know, you probably want to look at an inverter that supports that, and we'll show those as we go through. Some of the other things to think about in sizing a grid tie with battery backup system. We talked about in the off-grid section, you size the inverter around the biggest load you want to run. So now let's go to a grid tie system, and that same still sort of holds true. We need to ask a couple questions. What's the biggest instantaneous load you want to start when you're in an off-grid scenario or grid down scenario? And with that, that gives us a minimum inverter size. Now the next question is, how many watts of PV do we want to put up? So how much, you know, if we want to put up, say, 6 kW of PV, then we're going to need at least a 6 kW inverter in order to sell that all back. Otherwise, we're just wasting PV. So the two things that you want to look at with a grid tie of battery backup is, what's the biggest load you want to run in any 1 second, and then how many watts of PV do you want to put up? And those two are going to help you size the inverters and the charge controllers. Now, on battery banks, I didn't talk about it in off-grid, but typically when we size the battery bank, for an off-grid scenario, we go for 2 to 3 days of redundancy, and we also look at not going below 50% state of charge. For normal, everyday use of a lead-acid battery, a flooded battery, we typically don't like to go below 50% just for longevity of the battery. Now, if you're doing a grid tie with battery backup, that changes. You need to know, first of all, what's the time frame you want to run the loads, you know, if it's 12 hours, 24 hours, and that will help you decide how much battery you need. The other factor that we change is, instead of that 50% state of charge, the rule of thumb on battery-based grid tie is we're allowed to go to 80% depth of charge. Just because we do it so infrequently, we're not afraid of abusing the batteries at that one point, because it's just so infrequent. The batteries are going to die of age before they die of use, if that makes sense. And if anybody's got any questions, definitely feel free to type them in as we go. I didn't mention that, but I don't want you to hold your questions till the end. So you know, if you got one, go ahead and throw it out there, and we'll answer it. But again, grid tie of battery backup will sell to the grid, will give you backup power when the grid is not there. Key words: backup power when the grid is not there. A lot of people have bought purely grid tie systems and were not aware that it wouldn't have power when the grid was down. And now, unfortunately, they're candidates for AC coupled systems. And I say unfortunately because that means they've got to spend more money. So AC coupled, again, it adds battery backup to a purely grid tie system. It does add some level of complexity to the system. So in my opinion, it's best suited for an existing grid tie system as an add-on. There is an exception to that if you're wanting to power a whole village off-grid. SMA makes a very nice AC coupled setup where it does 3-stage charging and everything else. So if you're looking to do it as like a village power system, AC coupled has some merit. But if you're looking at it as an individual residence, my opinion is AC coupled is a little bit of a clunky add-on, and it has some drawbacks. So I solely prefer to do purely grid tie, being a battery-based grid tie, sorry about that, than AC coupled. But if there's an existing pure grid tie inverter already on site, AC coupled makes a lot of sense. Our pre-wired systems, some of the benefit to that is that we take a lot of that complexity out. So as you saw earlier in that picture, that was a shelf out of this system. And basically what you would end up doing is you'd bring your grid tie inverter to 2 terminal blocks labeled grid tie inverter. You'd run a critical loads panel off in the terminal blocks labeled critical loads, and you'd bring the utility power to the terminal blocks labeled utility power. And then that's pretty much all there is to it. Install the batteries, turn it on, verify the programming, and this is going to sit there and do its thing. Under normal conditions, it's just going to sit dormant, keep the batteries floated, and when the grid goes down, it's going to take over and become an AC coupled off-grid system for you. And I do have a question here. Let me expand this up so I can see it. I need to mention that it will usually be more cost-effective to choose the grid type battery backup when you know that they want battery backup only than to buy 2 inverters. Basically what Kim is saying is that if you were looking at it from a financial standpoint, you're going to be ahead of the game to do a DC coupled or a battery-based grid tie system from the start than you would to do, say, a Fronius grid tie inverter now and add this system to it a year from now. Just because you're buying 2 inverters, whereas if you do the battery-based grid tie, you're buying a single inverter and a charge controller. So it's going to be, you know, a little less money and obviously less installer time on site because it's 1 install instead of 2. So those are the hard questions you need to ask yourself, is when you're looking at doing renewable energy, do I really want to go purely grid tie, or do I want to add some batteries to this? And that's a hard decision to make at the time of writing the check, because the batteries do add a cost to the system, and a lot of people will go with the lesser expensive route for quicker payback, and then unfortunately something like Sandy comes through and you realize that your $20,000 system, you know, still let all your food spoil in your freezer and your refrigerator. So definitely take a hard look at that, think about it, and really weigh your options as far as battery based versus purely grid tied. Again, AC coupled, basically for the purpose of this exercise, we're going to consider it an add-on to an existing grid tie system. We're not going to look at it as a brand new install. If anybody does want to power a village and wants to do a brand new install with AC coupled, definitely get a hold of us. You know, we'll work with SMA. We partner with them very well, and we can definitely do that. But for the scope of this, we'll stay away from that one. So we're going to be a little inverter specific now, and I'm going to talk about the FX series. So the FX series comes in either an FX or a GFX, and the G stands for grid tie. Now there's also a V that can be thrown in there, which doesn't mean anything as far as the inverter goes, whether it sells or not. Basically that means it's a vented versus a sealed unit. So it's going to make it a little more powerful is the difference. So with that in mind, the FX or GVFX is a 120 volt only per unit. It's either grid tie or off grid, depending on whether you get the G series or you don't get the G series. Again, the G is grid tie. And the G series does not play well with generators. So again, remembering that theory we talked about earlier, if you're doing a battery-based grid tie and think you want generator support, you want to pay attention to the rest of this, and I'll point out the ones that do play well with generators. The benefit of the FX series is it's a smaller scale, so it's expandable. You can stack up to 10 FXs on a system. They have a hub that allows you to plug everything together, and then the mate plugs into the hub and monitors the system. If you're doing a grid tie, you can put the Classic on there. The Classic comes with all the monitoring software. We'll talk about that a little later. Just depends on what you need. Like I say, if you need a small 120 volt only grid tie system, this is a very affordable, very capable grid tie inverter, but it does not support generator. One of the other benefits of it is it does come in 12, 24, and 48 volt models. I do want to point out as well that the FX series does support generators very well. The GFX or GVFX does not support generators very well. Picture of a quad off-grid system. As you can see there, this has 4 inverters, 3 classics, a Mate 3, of course the hub, and this box down here is the PSX 240, which is an auto transformer. And what that does is it allows one inverter to make the 120 240, and the other 3 can go to sleep until they're needed. So you save a lot of energy, on idle losses of the inverters sitting there just running for no reason. Again, this was built as seen and shipped out on a sheet of marine grade finished plywood, so it was ready just to hang on the wall and plug battery cables and AC in and AC out to. The Radian, made by Outback as well. Basically what the Radian is, it's what the FX series was supposed to be but never got finished. The Radian is 2 FX inverters inside the box. It's so therefore it is 120 240. It's redundant, so if one of the inverters fails, you can still run on one only and have a 4 kW machine instead of an 8 kW. It is has 2 AC inputs. So you remember before we talked about the FX not supporting generator. The Radian supports generators very well. It has dual inputs, so you can bring a utility grid into one, set it up for grid tie. You can bring the generator into the other, and it'll never sell back to the generator. Therefore, with that in mind, this thing does do grid tie, and it does do off-grid. So this basically is an all-around inverter for anything battery-based. Some of the drawbacks of this unit maybe are that it's 8,000 watts, so it's fairly large if you don't need that big of an inverter. The other one is that it's 48-volt battery only, which are not necessarily drawbacks. I just point that out. There's not quite as flexible if there's a reason you want to do 24-volt battery. It does grid tie, does off-grid. It will AC couple, but when it's AC coupled, any of the Outback inverters, when they're AC coupled, need a way to disconnect the grid tie inverter from the utility grid. From the inverter. What happens in AC coupled is the grid tie inverter will push against the output of the battery-based inverter and physically make it run backwards and charge the batteries. There's no problem with that at all, except for some of the battery-based inverters, like the Outback inverters, don't regulate in reverse. Therefore, they will just keep charging, forever. So there needs to be a voltage sensing relay in there that will disconnect the grid tie inverter when the batteries get full. Now, on our pre-wired systems, that's all done automatically for you. All you need to do is verify the programming and run a fail-safe test yourself just to verify everything is doing what it's supposed to do before you leave site. But that disconnect circuit is all built in. If you are doing AC coupled with the Radian and you want to do generator as well, you do need to make accommodations for the grid tie inverter to be disconnected when the generator is running. Otherwise, the grid tie inverter will connect to the generator. Again, if it's a pre-wired system, we would do that accommodation for you if we knew that was needed. Picture of the inside of the Radian E-panel. Again, like I said earlier, fairly similar in concept, a little different in layout. PV positive bus bars over here on the right, AC in, AC out, AC in 1, AC in 2, neutral, PV positive, and then battery negative is up here. And I point this out because this is thrown a little bit of a curve to a couple people out there. They don't see the negative bus bar up here, and they see this white bus bar and end up hooking PV negative to that, and the charge controls don't work too well. So just something to point out, the DC negative is up here on the shunt on this one. Battery cables hook here, and then there's a positive combiner bar down here for one big battery cable down here. The Radian E-panel is available multi-flavors, so if you wanted just the E-panel not pre-wired, we have a single Radian E-panel, we have a single prepped for a single classic, and a single prepped for a dual classic, and then we have a master Radian E-panel that will do 2 Radians. That's something that Outback doesn't even do. So we can pre-wire 2 Radians with the official bypass in one E-panel, and then of course we have the slave E-panel for the second Radian that wouldn't need any AC breakers. Kim's asking me to make mention that you can use the Classic with any inverter system. It has its own communication systems. I think what she's pointing out is that we get asked a lot is that when I'm buying this system, I'm not really familiar with the system, if you will. So I read, the Outback stuff, and well, can I really use the Classic because it doesn't talk to the Outback, or it doesn't talk to the Xantrex, or it doesn't talk to the SMA? And the simple answer is it really doesn't need to talk to it. The only things that really happen when they talk to each other is they share battery temperature sensor, and they may coordinate like equalized charge. So they don't really need to talk to each other. So that's really a non-issue. But to pacify that, what we are doing is we're slowly working what we call translator modules into the marketplace that will allow our controller to plug into anybody else's inverter. We have the SMA box done. We can now mimic the SMA charge controller. So when you go onto the Sunny Island, start pushing buttons, and you go to the charge controller, the Classic actually shows up, and you can read all the data from it. And basically, in the case of the SMA system, the inverter has so much technology in it, they wanted control of the charge controller. So the charge controllers do whatever the SMA Sunny Island tells them to do, and it's a very neat system. But we'll be working on that for all the systems as we go. Kim also wants me to make mention that the Radian E-panel is easier to wire than the Outback load center. It's a little more room to get in there. I mean, I'm not going to sugarcoat it. It's still a little bit of a challenge getting the bolts and stuff in the bus bars. I just installed one of these at the boss's house actually, and it's not bad. It's just once you get used to it, it's pretty easy to do. But it's a little bit of a project, but it is definitely more room, and it's more convenient than the load center that Outback put out. There's a CAD drawing of a dual Radian system on a backplate. What we do now, we can do this two ways. We can do a dual Radian as a complete system like you see there, and you can hire 4 or 5 of your real rugged buddies and put it on the wall. Well, we actually have a split backplate, which basically is cut right below the system right here. Oh, no, I'm sorry. It's cut right up here, right above the E-panels. So what happens is this whole bottom section is all pre-wired on a backplate, and the inverters come mounted on another backplate. So you'll mount the bottom half to the wall, and then you'll pick the top half up, mount it to the wall, then you'll go inside and push the wires up through and land them under the spring terminals of the 2 Outback inverters and put the screws into the Outback inverters. It's probably about an hour-and-a-half project to wire those two together on site, but it makes it much more manageable to get it up on the wall. So again, we're very, very flexible in this scenario. We can wire these as a full complete package like this if you've got a way to get them on the wall, or we can actually break them up in pieces and do what I would call like a semi pre-wired, and makes it a little bit easier to manage if you don't have quite as many people on site. Is there any code issues of having AC and DC in the same box? No, there isn't. The only issue is that the DC wiring have the same insulation rating as the AC, or actually I shouldn't say it that way. The insulation rating needs to be of the highest voltage in the box. So if you're doing AC in there, it's going to be 600 volt rating on all wiring, and all the wiring we use carries that rating, so there's no concerns there. Also being asked to explain the bottom box in this picture. That bottom box is what we call a battery combiner box. It has 1,000 amp shunt and 1,000 amp bus bars in it. So what that allows you to do is several different things, but in the case of the Radian, remember I said it was 2 inverters in each Radian, so now you have 4 battery breakers there. So you have 4 175 amp battery breakers. So it allows you to bring those cables down to the 1,000 amp bus bars in here and run one big set of cables back to the battery bank, or say a pair of 4-aught cables or something, but it just makes a place to combine all of that wiring with high enough ampacity to do the job. It can also be used in the reverse. It has 12 breaker spaces in it, so it will hold all the way from our 5 amp breakers up to our 250 amp breakers, and you can take that and use, say you for some reason end up with 8 strings of AGM batteries. Not necessarily a good design idea, but you've been handed this job and there's no way around it. You can put the battery combiner in and run equal distance cables for every string, and that way the resistance will stay about the same, and they'll charge much more evenly than they would if you say paralleled 8 strings together and fed it cross corner. The middle strings would probably never really get charged very well in that scenario. So it's a very useful box. You can find it on our price list under battery accessories. Any questions on that, get a hold of Alti or us here at MidNite. And Magnum Energy, undoubtedly probably one of the more affordable inverters out there and more versatile, I guess you'd say. It does not grid tie. I want to point that out in big, bold letters. Does not grid tie. It will use the grid to charge batteries, but it will not sell back. They have models in 120, and they have models in 120, 240. They have models in 12, 24, and 48 volts. The 120, 240 only comes in 24 and 48. They have various wattages available, all the way from, I believe, 600 or 800 watts all the way up through to 4,400 watts. They have lower cost options with modified sine wave, and they have a full line of pure sine wave inverters. Everybody else's inverters are purely sine wave. Magnum is the only one you'll see here today that actually still offers a modified sine wave version as well. And again, remember I was talking about battery charger. I've seen a lot of the modified sine wave Magnums installed just for battery chargers. They have undoubtedly one of the better battery chargers in the market. It's power factor corrected, very efficient and very robust. Again, they are stackable. The PAE series can stack up to 4. The regular series can stack up to 2. They're all vented, so if you're in an area like Hawaii and that's a concern to you, again, the Outback is sealed. The Sunny Island is fairly well sealed, not necessarily sealed, but well protected. The Radian, not sealed, but it does have conformal coating on most of the boards, so those things are things to take into consideration. If you're in an area where there's a lot of salt water, corrosive environment, you may want to look at like the Outback FX series that's sealed. And again, off-grid only. For the classification of this slideshow, we will call this off-grid only. It can grid interact, but it cannot sell. I do have a question. Okay, yeah, Kim is asking me to explain why in AC coupled you need a critical loads panel. And what I mean by that is if you don't have any renewable energy on site right now, you've got one main panel where your utility comes in with all your circuit breakers in it. And if you want to do backup, you need to break the loads out that you want to back up, i.e. critical loads. So you can't just simply backfeed that panel because, well, A, you can't really power the whole house because you've probably got a lot of electric loads that are too big for the inverter. And B, it would backfeed the grid, which could potentially kill somebody and maybe blow up your system. So you need a critical loads panel, and what happens is typically it'll get installed right beside the main panel, and the electrician will pull the critical loads out of the main panel and bring them over to the critical loads panel. And then the inverter goes in the middle between the two. So again, you do need that backup panel because the loads do need to be separated. Just because you cannot backfeed the main panel, you will end up backfeeding the grid and could possibly kill somebody doing something like that. More likely you would actually blow up your inverter, probably would never be able to power the grid just because it's so big. So again, a quick rundown: 120, 120, 240, various wattages all the way up to 4,400 watts, stackable up to 4 units, vented only, off-grid only, 12, 24, and 48 volt models. And we'll pre-wire any one of those all the way from the 600 watt unit all the way up through to a quad stack of 44, 48 PAEs. XW. Now this is a unique inverter. I've played with a few of these. A very nice inverter. This inverter is very similar to the Radian. It has grid tie or off-grid, does both right out of the package. 120, 240 out of a single unit. However, you can reconfigure it, I understand, for 120 only if you want to. You cannot do that on the Radian. It does have 2 AC inputs, AC1 for grid, AC2 for generator. Where it starts to differ from the Radian is that it comes in multiple sizes and multiple voltages. So we can get this in a 4.5 or a 6 kW 48 volt inverter, or we can get it as a 4 kilowatt 24 volt inverter. So that offers some flexibility, and they're a very robust inverters. So when they say 6 kilowatt, it will really do 6 kilowatt and surge to a whole lot more than that. XW also does generator support, which is one of the only ones that do it. SMA does generator support, and what generator support is let's say you've got a 5 kW generator, you live off grid, and you got a 6 kW Xantrex XW, and you've got a 7 or 8 kW motor load that you want to start, or whatever the load may be, and you only do it rarely, so you really don't want to buy the second inverter just to start that load. You go fire up your generator, and then you start the load, and the two will combine together to make an 11 kW power system at that point and start your load. So again, I want to point out generator support. That is a very neat feature for off-grid folks, and it's only available in the XW and the SMA Sunny Island. Magnum is working towards it. I believe they're going to have a new inverter out soon that will do generator support, but I also understand it's 120 volts only. I'm not sure that for certain. I will look into that and have that information at a later date. Any questions on that, definitely give us a call. I want to go back to AC coupling a little bit, and we'll probably talk about this more, but redundancy is usually good in this department. What I was mentioning earlier about having to disconnect the grid tie inverter when the batteries are full because they don't regulate in reverse. The Xantrex, however, is smart enough to know the batteries are getting full, and it does what they call frequency dithering. And what it'll do is as the batteries start to get full, program, something you've programmed in, said, okay, at 59 volts I want my batteries to be considered full. It will dither the frequency enough to actually kick the grid tie inverter offline and start charging the batteries. And when the batteries fall back down, it will bring the frequency back into spec and let the grid tie inverter connect back up and charge the batteries again. So that's completely automated, no intervention needed by you at all. The only place you have to get creative is if you decide you want to hook a generator up to this as well and you want it automated. Whenever the generator's on, you need to disconnect the grid tie inverter. If it's manual, you can have an interlocking switch that allows them not to turn the generator on with the grid tie on. So it's kind of an either or, almost like a transfer switch. Again, a quick rundown of the XW. It's grid tie or off grid out of the same box, 120, 240 in a single unit. It's available as 4.5, 6 kilowatt 48 volt or 4 kW 24 volt. It is a single inverter in the box, so therefore it only has one battery breaker, a little easier to cable up, a little more room in the box. And it does have two inputs, one for generator and one for utility. And unlike the Radian, if you wanted the Xantrex to work and just wanted it to work and just wanted it to make power, didn't care about selling or any of the other stuff, it does have a sort of very, very basic display on it that allows you to turn the inverter off and on and monitor a couple things on it and make it an inverter. So if you wanted to just power your house from this and didn't care about grid tie or any of that, you could install the Xantrex right out of the box, just push the on button and have AC power. Whereas the Radian, you do need the Mate 3. Just as a reference. Again, when we pre-wire these, we would include the Mate 3, or on the Xantrex we would include the system control panel, but I just wanted to point that out. That is a unique feature of the Xantrex, is it can physically be turned on and used out of the box at its defaults without, an extra device if you want. Not sure I understand that question from Kim. The XW can have generator and be automated. It will kick off from AC coupled and go to generator. Maybe that's a question or maybe it's a statement. The XW, again, if it's AC coupled, it has two inputs. So if it's AC coupled, the utility grid is going to AC1 and the critical loads are going to AC out. And of course the grid tie inverter is going to AC out, and it's backfeeding through the XW. And what the XW will do is frequency dither on full battery to disconnect the grid tie inverter so it doesn't overcharge. Now, if you want to put a generator into the mix, the grid tie inverter physically needs to be disconnected, not kicked offline. It physically needs to be disconnected, because what will happen is as soon as the generator starts, the XW will close its internal relay, just like any other inverter out there, and it will hook the input directly to the output. So now the grid tie inverter will see the generator, and in 75% of the cases, it'll be too dirty for it ever to turn on. But if it were to turn on, it could damage your generator. So provisions need to be made for that. And if we know you want to auto start a generator on an XW, we can make those provisions in the pre-wired system. The SMA Sunny Island, rather new to us, not new to the market. SMA has been around for a long time. Undoubtedly probably one of the best inverters out there as far as quality, I guess, robustness, power output. No, it's just a very nice inverter. I mean, it does come with a little bit of a price tag, but it's definitely an inverter to be looked at. It is a grid tie or off-grid, all in the same package. Supports both. It is 120 volts only, so that comes into play, and we'll talk about that a little bit more here. It is a single input only as well, which is also another issue, but we have a solution for that as well. It is available in a 4.5 and a 6 kW unit. We predominantly use the 6 kW units because they are about the same price and about the same weight. It is stackable up to 4 units, and that is what is called a cluster to SMA. SMA themselves can do multi-clusters, but you get into the multi-cluster box, which again is going down the road of village power and a little bit more than we probably want to elaborate on in this slideshow. So for this purposes of this talk, we're going to consider the Sunny Island up to 4 units only. If you need more than that, contact us and we will work with you on that. It is 48 volts only. So what you see in the picture here is the bottom box is our E-panel for the Sunny Island. We actually, SMA has been beating on us for 3 years to do this. Finally got it done. It matches their inverter perfectly. Same contour, same shape, same color. And what you see on the top is our auto transformer. They have what they call a smart former, and it's about twice as big as that, and it's about twice as much money as needs to be. So what we did is we designed a chassis and used their core. So we use their toroid and put it in our chassis, and we use that if you're going to use a single Sunny Island and need 240 volts. So why would you do that? You want to AC couple a Sunny Island, you need 240 volts because most grid tie inverter is going to be 240 volts. So what you're looking at there is a complete AC coupled 120 volt 6 kW system, but with the autoformer it becomes 240. Now inside the E-panel we have what we call our SMARB, or SMA relay board, and what that does is that during what we call grid up conditions, or when the grid is present, the SMARB turns off the auto transformer and connects the critical loads directly to the utility grid, so you have 240 at the critical loads panel and everybody's happy, everything's ready, and as soon as the grid fails the autoformer gets turned on and the inverter gets connected right to the loads, and the loads automatically see 240 volts flawlessly, and as soon as the grid comes back, of course that relay board switches everything back the way it was and everything is good to go. So AC coupled, I didn't mention it earlier, but there's another feature of AC coupled that most manufacturers suffer from, and that is capacity. So say you have a 4 kW grid tie system, you need a 4 kW battery-based inverter. And that is a true statement for everybody's inverter except for SMA's Sunny Island. The Sunny Island is capable of about a 2-to-1 ratio. So if you had a 6 or 8 kW or say 12 kW grid tie system, you could put it all on a single Sunny Island. And again, that autoformer and that transfer switch take care of the current flow problem, because the Sunny Island, being 120 only, is limited to 56 amps at 120 volts. But where we move the grid tie inverter between utility and backup, that no longer becomes a problem. Again, what is the model number for this SIE panel? I confess I don't have that memorized. I will pull that up on a browser here on another computer while we're talking and try to get you that model number, or maybe actually Kim can do that and put it in the question box for me. They're all on our price list. If you go to Prewired AC coupled, you'll see all of the SMA systems all priced out and wired there, but maybe Kim can get that for me. Synchronous paralleling or actual transfer. It's an actual transfer. Most of the battery-based inverters don't actually do synchronous paralleling just because of the tear losses. So what they do is the internal relay is closed in the inverter, and the loads are powered through that relay. So as soon as the grid fails, that relay snaps instantly right over to the inverter. And when I say instantly, it's usually about, I believe, less than 1 or 2 cycles, maybe 3 or 4 cycles. It's fast enough that you may or may not even see just a little flicker in the lights when it happens. So it's pretty seamless. Computers will not reboot, nothing like that. But it's not truly running in parallel. So in other words, what the question was synchronous paralleling or actual transferring. Some UPSs, like you buy for your computer, smaller UPSs, they actually run the computer off their output inverter all the time from the battery, and then they have a separate battery charger in the box charging the battery. So the two, there's no pass-through, but just for efficiency standpoint, that would be horribly inefficient on a whole house standpoint. So it is, it's an actual transfer, but it's done in about 2 or 3 cycles, probably about 1/100th of a second. And the model number of what you're looking at there is MNSI 6048-ACCPL. And again, that is right on our price list under pre-wired inverters, pre-wired, AC coupled. Picture of a quad stack of Sunny Islands. Again, what we've got in the Sunny Island E-panel line is we have a single Sunny Island E-panel. We have a dual master, which has a bypass capable of 2 Sunny Islands. We have a quad master, which is capable of bypassing 4 Sunny Islands. We have a 3-phase master, which is capable of 3 Sunny Islands. And then we have a slave E-panel, which basically it would be used in any system that has more than 1 Sunny Island. So if you've got a quad like this one, you'd order a quad master and 3 slaves. Something I've seen a couple people do already is, remember we talked about the battery combiner box and the fact that it can hold battery breakers. I've seen people take the battery combiner box and actually use it to replace the 3 slave E-panels. Put their battery breakers down here for the 3 slaves, and then they pipe right into the 3 E-panels from the battery combiner and pull their AC wiring right through there as well, saving themselves a few coins on the E-panels if they don't feel the need for that extra. Now, that wraps up inverters. Before I go on, I will talk a little bit more about AC coupled. I didn't spend a lot of time on AC coupled because the webinar was supposed to be solely on pre-wired. But again, with AC coupled, the questions you have to ask is what kind of inverter is already there, because you're limited to, for the most case, you want to consider it limited to a 1-to-1 ratio. So if you roll up on site and the customer has 3 strings of N phase and they've got 6 kW of N phase, 2 kW per string, we'll say, and they want AC coupled, but they are on a budget. They want to do it as affordable as possible. So then you can take the Magnum 4024 pre-wired system. You take 2 strings of the N phase and move them over to the Magnum and leave the 3rd string run the utility grid, and you're good to go. Now, if that had been a 6 kW Fronius inverter, for instance, you wouldn't be able to put that on a Magnum 4 kW system, so you would need a 6 kW battery-based inverter. And again, that holds true on everybody except for SMA. SMA can tolerate about a 2-to-1 ratio, and if there's a Sunny Boy in the system and you really want to get fancy, you do the Sunny Island and you will get frequency dithering, and it will not just shut it off. It will throttle it back to keep the batteries properly charged. But again, I want to stress that in an emergency situation, a Sandy type scenario, the grid is down because of a storm, we really don't care about 3-stage charging on the batteries. We really don't care about being mean to the batteries. We're going to use them. We're going to use the daylights out of them, and when the grid comes back, they'll go back to float charge, and they'll sit there for another year or 2. So if the system is solely being installed as a emergency backup power, don't worry about how you treat the batteries in that respect, because they're getting maintained all the time, and you're going to use them once or twice a year. And at that one or two occasions, we're not really worried about being mean to them. AC couple on Sunny Islands requires either SMA that will frequency shift or special considerations. No, I didn't mention that, but the Sunny Island itself frequency shifts. Frequency dithers like the like the Xantrex, I'm sorry. So if you have a Fronius inverter, and Fronius is a bad example because I think they void your warranty if you're AC couple. But if you have an inverter out there that is not a Sunny Boy inverter, and you hook it up to a Sunny Island, the same thing will happen as it does on the Xantrex. When the batteries get full, the frequency will dither, it'll kick the inverter offline, the batteries will drain back down a little bit, and then it comes back into line and everything is good again. So the SMA and the Xantrex XW frequency dither. The Magnum and the Outback do not. So if you're doing AC coupled and that's on your mind, those two frequency dither. The difference between the SMA is it goes a step farther, and if it's talking to a sunny boy, it can frequency dither in little bites, and it won't turn the inverter off. It will throttle it back just like a charge controller would, if you will. So if you've got a 6 kW grid tie sunny boy and you only need 4 kW to maintain the batteries, it will throttle it back down to 4 kW and maintain the batteries. So it's a little more elegant, and that comes back to that powering a village idea, because if you're doing AC coupled as a mainstay off-grid, you need 3-stage charging to properly charge the batteries. Otherwise, you're going to destroy the batteries in a short period of time. If it's an emergency backup, again, forget about the batteries. We don't care about the batteries because under normal conditions, they're being pampered like crazy by the grid. So when the grid goes down that 1 or 2 times a year, we're going to go ahead and use the daylights out of them and not worry about it. Yeah, so like I say, I didn't spend a lot of time on AC coupled. I'm more than happy to do a whole webinar on AC coupled, or I'm more than happy to answer any questions on AC coupled. Feel free to call me, email me, rattle me. I'm not going to venture too far down that road unless people want me to, because I probably running up on a clock here, and I still have quite a bit to talk about. Yes, okay. Yeah, well, we will work with Andrea and see if we can't set up a webinar on AC coupled. I think that would be great, especially here on the East Coast with the storms. We'll set that up. Keep an eye on our website. We'll have it on the right-hand side under our schedule. So, why pre-wired combiners? Here you're looking at a homebrew combiner. Again, it's one of those pictures that was sent to me that before they replaced it. Some of the things I like is the green grounding screw for the lost screw down here. But just notice the rust and the corrosion and the different things, you know, just reasons why pre-wired. So here's a pre-wired. This particular one has become an industry favorite. This is being used on utility farms all over the place. They love it because it's pre-wired. They hang it on their rails. They bring their cables in, plug them in. They keep on moving. Fast, easy. It just makes it much more elegant. The one thing I point out to a few people, I guess in Canada, the rule is if you don't have an electrician's license, you can install PV panels and you can wire them to the combiner box as long as you don't have to cut a wire. So these become quite popular in Canada as well because they can plug them in. That way they don't need the electrician on site for the combiner. So it allows for, I guess what you would say is less skilled labor on site to actually wire up the combiner box. We can do these with any one of our combiners we already sell. We can pre-wire it for fuses or circuit breakers. If it's a combiner box, it will take circuit breakers. We do pre-wire only the MC4 style plugs. We do not pre-wire Tyco. It's just too confusing. There's too many adapters and too much stuff. So we only do MC4. We have models that are NEMA 3R and we have models that are NEMA 4X. And every one of our combiner boxes are powder-coated aluminum, so they will not rust or they will not turn to dust like fiberglass will, say in Arizona or in the desert. Here's a low voltage 6-string pre-wired combiner for 150 volt charge controller, if you will. Again, we could do a 3-string 300 volt charge controller breakers in there for like a classic 250, or we could do fuses and do 4 strings for grid tie, like you saw on the previous slide. We can even pre-wire our disconnecting combiners. This one here, as you see, is birdhouse compatible, which is another whole webinar, but our new disconnecting combiners interface with our birdhouse, which is a rapid system shutdown device. It's a single button with visual and audio indication on the outside of the house that wires up to the combiner boxes and battery-based inverter breakers or charge controller breakers and shuts the whole system down with one push of a button over standard Cat5 cable. Definitely something we need to have a webinar on. It is something that's coming in the new electrical code. NEC code 2014 is going to require what we call rapid system shutdown. Some of you might have been at my presentation at the Alt-E dealer conference this year in New Hampshire. We did a presentation on just that. But basically what the NEC is going to require is that the whole system be brought to safe operational voltages of, I believe it's less than 40 volts, but don't quote me on that. And they're giving you so many meters from the solar panels and so many meters from the batteries. So basically what they're saying is the combiner box and all battery-based breakers need to be turned off with a single push of a button within X many seconds, and I believe it's a couple seconds. It may be 10 seconds. Again, don't quote me on that. I do believe we have that document on our website, the actual article. It's going to be in the 2014 code. Again, I'm happy to do another webinar on just rapid system shutdown, as I think it deserves its own hour versus trying to talk about it here. Any questions, do feel free to get a hold of me on that. I'm going to quickly talk about the classic charge controller. I don't know if I've put everybody to sleep yet, but this is our evil genius, Bob. He is the engineer behind the classic charge controller. He was also the engineer behind the Outback Power charge controller and one of the leading engineers on the inverter, the FX inverter lines. So as you can see here, the classic, when it's alone in the picture, necessarily doesn't do a lot of justice for itself in size. But as you can see here, we've been able to keep the size fairly minimal. It's a very low impact, very powerful device when compared to the others here. The most powerful device out of the four you see there, on a 12-volt battery, the classic 150 is good for 96 amps. On a 48-volt battery, it's still good for about 82 amps. So it's a good, honest-to-goodness 80-amp controller. And, just very, very versatile, very powerful, does a lot of different things. What we do have is we have the Classic and we have the Classic Lite. So I'm going to spend a few minutes on features. The Classic has arc fault in it. The Classic Lite does not have arc fault. The difference between a Classic and a Classic Lite is the Lite has no display and no buttons. So as you can see, it has LEDs to tell you what's going on. And if you pop that cover off, it's got dip switches to let you program it. The Classic Lite as well does not have arc fault where the Classic does. So that's the differences between them. Everything else they both do and do exactly the same. So they both have ground fault, they both have Ethernet on board, they both speak openly published Modbus, they have RS-232. They do some unique things. So with the Classic Lite, you're going to save a few bucks, and if you're not into pushing buttons and you like your PC anyways, you can use the free software that comes with it to actually program the Classic Lite right from your PC. I do have a couple screenshots of that in a little bit here that we'll talk about, but it allows you to do anything right from the computer screen that you can do from the display of the regular Classic. So it makes it really, really elegant. Another thing that's kind of unique is we have what we call Follow Me, and unlike what we did when we did the Outback controller and hubs and special equipment, limitations and everything, Follow Me is a daisy chain. It goes around in a circle, and there is no master, there is no slave per se. And again, this is another webinar, but I'll touch on it. And the one Classic will ask its neighbor, what am I supposed to do now? And that goes around the loop like that. So if any one of the 240 Classics decide it's time to go to float, the next guy is going to get that memo and it's going to populate right around the loop within a couple seconds. They're all going to go to float. So it's a very elegant solution, and the benefit of it is there's no hubs, there's no switches, there's no nothing. It's standard 4-conductor phone cable, standard RJ11 jacks. Literally off-the-shelf phone cable right from Walmart to plug these things together if you want to. We do sell networking cables as well, and you can build your own out of Cat5 cable and RJ11 jacks, but it is literally off-the-shelf phone cables and literally can stack up to about 240 controllers in one Follow Me loop. The other thing you can do, or I should say the limitation to that number, is the Modbus addressing. And that follows through to the next thing I'm going to talk about, is that the Classic and the Classic Lite, the Classics themselves, the boards behind the box, if you will, can be addressed. And they can have an address from 1 to 254. And what that does for you is if you address, say, 253 Classic Lites as 1, 2, 3, etc., then you can go from your standard Classic plugged into the Follow Me network, and you can use the up and down arrows and scroll through Classic 1, Classic 2, Classic 3, and you can see all the other Classics from that one display. Or if you wanted a second display in the house, then you could just scroll through all the Classics on one single display. So it allows you full control. You can program it from that. You can view it from that, anything. If you are plugging them into the internet, they each do need their own Ethernet jack. So I apologize, but you will need 254 Ethernet cables if you're going to plug them all into the internet. Some of the other features are MPPT for wind, much more programmability for micro hydro, fuel cells, different battery chemistries. We have logic inputs so that if you're using a battery management system, we can stop charging when the when the management system tells us to, instead of having to have the old clunky relay that disconnects you. We actually take a logic signal from them and just stop charging when they tell us to. Just a lot of unique features. I mean, it is definitely the most sophisticated, powerful controller out there. It's been 7 years in the making, and for reference, Bobby did the MX60 in less than a year. Again, to sum it up, Classic and Classic Lite pretty much identical, except for the Classic Lite does not have arc fault protection, and the Classic Lite does not have buttons and a display. It has LEDs and a dip switch. And I'm being asked for a webinar on rapid system shutdown too. I know Kim will take note of that. Kim, make sure you remind me later that we need to schedule rapid system shutdown webinars as well as AC coupled webinars. So another unique thing we did early on in the early days of the Classic was we did logging, and we did a lot of logging. We actually set up 3 identical arrays literally on the single plane on my roof here. We did this on 6 different sites, and we had APRS World build us custom data loggers and calibrate everything and monitor and host this all for us. So it was all done by a third party. And what you're looking at here is just a typical week in Maine with 1,000 watts of PV on a Classic 150, an FM60, and an XW MPPT 60. And as you can see here, a little unique in daily harvest. Some of the things we get asked a lot about charge controllers is, what's its efficiency? Well, you could have a piece of electronic gear that's 100% efficient, and if your tracking algorithm is not very good or it's a little poor, the efficiency of the hardware makes no difference at all. It's like having 1,000 horsepower engine under the hood of your car, but your automatic transmission doesn't have any clutches in it, so it's not hooked on the rear end. You're not going anywhere. So the real meat and potatoes, if you will, is at the end of the day, how many kilowatt hours did we put into the battery bank or did we put into the utility grid? So this is why we put all this money into this monitoring, was to prove out the tracking algorithms, if you will. And as you can see, we routinely outdo most of the competition. There's a couple other charge controllers. We did not charge against the Apollo, stack up against the Apollo. We didn't test them. The biggest reason was that we tested them real quickly and found out that they stacked up about like the Outback of the Xantrex. So we weren't the 2 most popular. The Morningstar, however, is pretty neck and neck. Morningstar has a very good tracking algorithm as well. So if we were to have a chart on here for Morningstar, it would look very similar to the MidNite chart. Pretty much neck and neck. We beat them, they beat us. It's within 0.25% all the time. The one thing that I will say sets us apart, though, is again we have superior features, more output power, easy to use online monitoring, stuff like that. But again, just showing daily, production from the 3 controllers. And if you'll notice, the Xantrex XW actually does a very good job at tracking. It's slow and it's not as efficient because it's a single cylinder unit. But you'll notice it's consistent. Whereas you notice the Outback is not so consistent. It tends to get stuck at times, a little bit different. And that all comes down to tracking algorithm, because hardware-wise, the MidNite and the Outback are probably almost identical efficiency-wise. It's really just software. That's what it comes down to. Again, follow me networking. I won't bore you a lot more with that. We talked about that earlier. This system happens to be powering a private island off Massachusetts that may be owned by the Forbes family. This is 250 KS Classics. There is a massive 120 volt battery bank on the other side here, and there's I believe it's 100 kW. The name escapes me now. There's a 100 kW inverter system here powering the whole island. But anyways, this was just a very unique follow me setup. You know, it's a nice clean installation. I just love this picture. And my MidNite. I'm going to not talk about my MidNite right now. I'm going to come back to it in just a minute because I actually have it live on my desktop. So I'm going to go to the local app. We talked about earlier, the local app is a free software program that comes with the Classic. It's available to download on our site. It can be used remotely off-site over the internet, but you do need to port forward in your router like you would of a Morningstar. If you do know how to port forward and you want to use this from away, it does work very well for that. It does have, like I say, the configuration tab there right here. There's a configuration tab that allows you to program anything on the Classic that you can do from the MNGP. Wind curves, if you're doing a wind turbine, you can import a wind curve as an Excel file rather than having to push buttons on the Classic. So it's a very powerful tool. It comes with every Classic, and like I say, it's available to download right off our website. The one thing I do want to point out is if you do want to use it over the internet, like I said, it does require port forwarding in the router. So I'm going to briefly step away from this for a minute if I can. And I'm going to go to my MidNite. I'm being asked, does the local app work with the light? Yes, it does. Works very well with the light. Basically, if you can think of it, the light and the standard Classic, the circuit boards inside are identical. They're exactly the same boards. The only difference is the arc fault circuitry is left off the Classic light because we're assuming you're trying to save a little money and you're not worried about arc fault. But other than that, they're exactly the same. So the local app works very well with the Classic light. So my MidNite is a web-based monitoring program that again is free. So if you don't understand what port forwarding is, or you don't care what port forwarding is, you just want to be able to go to a website, you want to pick up your Android smartphone or your iPhone and you want to see what your Classic's doing at home while you're in Spain, this is for you, the My MidNite solution. Plug the Ethernet cable into the Classic, and that's all you do. You write down your MAC address and your device ID, which both can be found right on the Classic, and you go over to mymidnite.com, set up an account, register the Classics, each Classic you have, and to do that you simply put in the device ID and the MAC address, and each Classic will now show up, and you can categorize them. As you see here, I've got my office system down bottom, I've got my main solar system up top here. You can go in and you can configure that any way you want. You can show any different data you want. I talked about this a little bit in the beginning, but we got a bigger group. You can pull this out. You can pick the different values you want to chart, close the window, and those values show up. And you can change the size of the thing you want to look at. You don't want to look at so much data. We want to shrink that down and see what was really going on that one day. Now you can see the two clouds that come by. And you may be noticing as well over on the left-hand side, the values are changing. So let me go off screen. And when I go off screen, you'll notice this comes up and says updated. This is the last time it called into my MidNite. It calls in about every 5 minutes, piles the data on the server, and it updates this little window. So if you're on your smartphone and all you really want to know is what's going on at home right now, there it is. I'm making 126 watts. My battery's at 13.8, and I've been in float for 7,000 seconds, which is getting really close to being changed to hours and minutes. My MidNite is now in beta. You can go to our website, over to our forum, midniteforum.com, and you can grab the URL. You can go set up your My MidNite account, and we welcome everybody to do that because we're now in the stage of molding all the very cool features like email notifications and stuff like that, and we do everything based on customer input, so we really want everybody to try this, give us input, tell us how we can make it work better for you. But like I say, very full-featured web monitoring solution that requires you to do absolutely nothing but plug the cable into the charge controller. And I really want to point that out because the only other charge controller that talks over the internet is the Morningstar, and it has to be port forwarded, and it's a little bit clunky. It's sort of like our local app, but it's a little bit tougher actually. I do want to point out as well, you notice now the data on the left-hand side over there is changing as I move my mouse pointer. So we can see the date and the time and the actual data we have selected to view. So we can scroll through the day and see what took place there. We see an anomaly in the graph and we're like, well, what happened right there? Well, let's go look at that. We can see that cloud come by, we were at 59 watts. So it's kind of a neat, a really neat program, working extremely well. Again, it's in beta now, and we're welcoming everybody to beat on it and give us their feedback. So I'm going to go back to the slideshow, and let's see, from current slide. And that pretty much brings me to the end. So I'm hoping there's lots of good questions, lots of input, or maybe everybody's already asleep and fallen out of their chair. But anyways, like Andrea said earlier, here is the info to contact Alt-E or contact myself, or you can email Kim, K-I-M, at midnitesolar.com. Matt is one of our tech support gurus, M-A-T, at midnitesolar.com. You can pretty well see our email structure, so anybody you need to get a hold of at midnight, just throw their first name in there, and somebody will answer your questions and get back to you ASAP. All right, not getting any questions yet. I think I have Andrea unmuted, and I'll unmute Kim as well. She'll probably want to thank everybody for coming, so give me 1 second. Let me find that list. Okay, Kim, I've unmuted you as well. So.
Yep, I'm here. I think you had to mute me earlier because the peacocks were going off.
Yep, yeah, and I'll point that out, as Kim pointed out. We work from home, so sometimes you can hear unique things in the background, but that also makes it much easier to get a hold of us because we can never get away from the phone.
That's right. If it rings more than a couple times, we're guilted into picking it up.
Andrea, yes, you are unmuted. You should be.
Okay.
Yep.
Can you hear me now?
Yes, I can. Yep.
Okay, great. No, I just wanted to thank you, Ryan, again, and really, truly, your presentations are great, and we wish we all had our own personal Ryan right here with us. But that's why, all the great information that you guys give us, we, translate onto our website and provide for our customers as well. So it's a good partnership, and we look forward to setting up some more webinars here with you over the summer and this rest of the following year here.
Yeah, absolutely, and I also want to encourage everybody to come out to the fairs this summer. Alt-E and MidNite are going to be at the Solar Fest in Vermont, and I just got word that I believe Alt-E is going to be exhibiting with us at the Mother Earth News Fair in Pennsylvania in September.
Yeah, it'll be a good few upcoming months here, so we look forward to seeing everybody.
And Andrea, also you can, any of your customers that want to get on the email mailing list, so any updates that we have, press releases, they'll get it firsthand right from us as well.
All right, sounds good, guys. Thanks again. I'm going to scoot out, but we appreciate all of your help here.
Okay, well, thank everybody for coming, and again, don't be afraid to holler at us with any questions. We welcome all questions and all criticism, and suggestions or upcoming trainings. Anybody who wants to know anything, we're more than happy to schedule webinars and talk about anything you want us to talk about. That's it for me. Kim, you got anything else?
Nope, I'm good. Just thanks everybody for taking the time today. Ryan, did you get your job? You're only 15 minutes over, 16 minutes over.
Okay, well, thank you everybody for coming, and we'll see you next time.
Bye.
Bye.